This is part 2 of our lesson on angle theorems. In the first part of our lesson, we looked at some vocabulary, and in this part of the lesson, we are going to look at how to calculate missing angles in a diagram using some different angle theorems that you learned in elementary school. So I am just going to zoom in a little bit. So our first angle theorem is the complementary angle theorem. Complementary angles are not just angles that are nice and say nice things about each other. They are angles that add to 90 degrees. And I can spot that they're a pair of complementary angles because they should have that square in the corner that lets me know that they add to 90 degrees. So x plus y, these two angles add to 90 degrees. They make a right angle. So I can use that pattern to help me calculate missing angles if I have a diagram that's only partially labeled. So in this picture, I have two angles that together make that little square in the corner, so they make a right angle. So I have x and 25 degrees, and it's asking me to solve for x. So I know that these two angles together add to 90 degrees. And since we just finished our unit on equation solving, I would like you to write an equation and then solve it. So I know that x and 25, if I add them together they make a 90-degree angle. So I'm going to write x plus 25 equals 90. And then we are going to solve. So I would solve by subtracting 25 from both sides. And then I would calculate 90, take away 25, and I get that x is 65 degrees. And then here where it says x equals, I'm going to write 65 degrees. So complementary angles, you will always be able to spot them because they have a little square in the corner. All right, up next, we have the supplementary angle theorem. Supplementary angles are two angles that together make a perfectly straight line, or a straight angle. So I have angle x and angle y, and together they make a perfectly straight line. Straight lines or straight angles add to 180 degrees. That's what a straight angle is. So those two angles together should make 180 degrees. Now we have a question here. I have angle x, I have angle 45, and I see that together they make a straight line. So in a question with supplementary angles, I am always looking for the straight line, right? Complementary angles, I was looking for that square to say that it was 90 degrees. Supplementary angles, I'm looking for the straight line. So same thing as last time, we just finished our equation unit, so I would like you to practice some equations here. So we're going to say that these two angles together, x plus 45, equals a straight line, so 180 degrees. And then we are going to solve for x by subtracting 45 from both sides. And then 180, take away 45, is 135 degrees. All right, that was supplementary angles. They make straight lines. All right, our next one up is the reflex angle theorem. So reflex angles are angles that are bigger than 180 degrees. They remind me of Pac-Man, if you know what that is. And if I have two angles together that make a full circle, that's the reflex angle theorem. So it's a reflex angle and its non-reflex side, the acute side in this case. These two together make a full circle, and full circles add to 360 degrees. Now, what am I looking for on a reflex angle theorem question? I am looking for angles that go around in a full circle. That's how I know we're using the reflex angle theorem. All right, so in our example here, I have angle X, which is a reflex angle. I have this angle here, which is 67, and together they go all the way around in a full circle. So I know that I'm using the reflex angle theorem. So I want to make an equation. So I know that if I add X and 67, they make a full circle, so they equal 360 degrees. I am going to subtract 67 from both sides. And I'm going to do 360 take away 67, which is 293. So X is 293 degrees. Now that's a pretty big angle. So I am just going to look and check and make sure that it is the reflex one, right? If it was this little one on this side, 293 would be way too big for this little angle, but it makes sense for that big one on the back. All right, that was reflex angles. Last one on this particular page is my personal favorite of all angle theorems, and it is the opposite angle theorem. So the opposite angle theorem says that when you have two perfectly straight crossing lines, the angles on the opposite sides of those crossing lines are equal. So X would just equal Y. Right? The same thing would be true for this angle on this side and this angle on this side, the top and the bottom one, right? They would also be equal to each other. And when I'm doing the opposite angle theorem, I am looking for two perfectly straight lines that are crossing that just make a big X. That's how I know when to use the opposite angle theorem. So the example that I have here, I have two perfectly straight crossing lines. And I have this is 50 and this is X. So because they are perfectly straight crossing lines, I know that the angles that are on opposite sides of that X are going to be equal. So X is just going to equal 50. Does that require a calculation? No, it does not. X is just 50 degrees, right? I did not have to calculate anything. All right, so that was our first four angle theorems, our complementary, supplementary, reflex, and opposite angles. I will see you in the next video to talk about parallel lines.